Now it's time we discuss iterators running on lists. Consider the following example where we want to print each element of a linked list. We have a linked list of string defined with the name list, and in this loop here we are calling the get method on list one by one while increasing the index I starting from 0 all the way up to size -1. It sounds correct, but the problem here is every time we call get, it will find the element with index I by starting from the beginning of the list and skipping I elements and getting the next one. For example, if I is equal to 3, which means we are trying to access the fourth element, the get method will start from the beginning of the list, skip 3 elements, and then retrieve the fourth element and return that value. Now, when in the next iteration I becomes 4, get this time begins again from the beginning. This time skips 4 elements, then returns the fifth one. Now, if the linked list becomes very long, say if I becomes 10,000, this time get will start from again from the beginning and skip 10,000 elements and return the next one, and in the next iteration I will become 10,001, although it was just at the element before the one I want. It will go to the beginning once again and start jumping from there. So this is a very slow process, especially when the data size, when the number of elements in the list is very large. So we need to find a solution for this. And that's what the iterator provides us. This slide explains what I have already discussed, so I'm skipping that. So we will define a new data structure named iterator. As before, the iterator has a generic type, E, whatever E is. It's the element type actually. And it should provide a method we will call hasNext, which will be true if there is yet another element to access. Next, we'll get that element, and we'll remove the last element we had visited. So the data structure of an iterator will be like this. We have a list, in this example, composed of elements A, B, C, D, E. A is the first one. So you first initialize this iterator calling the iterator method of the list. This one is a linked list, so we will be calling the iterator method of this linked list. So iterator will just make this iterator point to the first element in the list. We don't know the content here. We don't know the content of the element is A yet because we have not called next. We just initialize it, and the initialization just makes it point to the first element. That's it. It doesn't tell what that element is. So to learn the content of an element, actually to learn the content of the element to which the iterator points to at the moment, you call the method named next. So what next does is, remember, the iterator was pointing to this element. So next says, yeah, okay, this element contains this value, so it returns the object. In this case, it will be just a character or a string, say a string A, and also immediately advances the iterator to the next element. So you do not need to call anything else to advance or shift the iterator to the next element. The moment you call the next method, it will give you the content of the current element, which was A by then, and move the iterator to the next one. So you can get the content of the current element only once. So don't forget to store it somewhere, as we will discuss later. Now, as this iterator is advancing and advancing, finally it will reach the last element, E. When the pointer has moved to the last element, and then you call next, it will give you E, but you should not call next once again, because you have already reached the end of the list and the iterator will fall out of the list. Therefore, every time you need to call next, first make sure that there is something to read. If you're not sure there is an element to read, calling next will cause a failure. Therefore, it's better to check if you're really stepping on an element or not using the has next method. Sorry. How about removal? Remember, initially we were our iterator was pointing to the first element, but we didn't know what it was. We called next, so we got A, but our iterator advanced to the next element. We don't know what that next element is. And when you say remove, now you should call remove only when you know what you're removing. You should not try to remove something that you're not sure about. Therefore, remove does not remove what it is currently pointing at, but it removes what it told you the last time, the last element that was visited. So while the iterator is pointing to the second element here, when you say remove, it will not remove B, but it will, because it has never told you that the content here is B. The last time it told you the content was when you called next, which returned A. Therefore, when you say remove, remove will remove A. In this example, A happened to be the first element in the linked list. Therefore, the front is also updated to point here. So going back to the code segment we had earlier, remember that our loop was iterating n times if the size of the list is n, but in every iteration, whenever you said get I, it had I operations. It had I minus 1 skip operations and 1 access operation. So the iteration here, the complexity of the loop body itself is O(n), because I can go as large as n. Okay, so the loop body has O(n) complexity, and we're repeating this loop body n times. So it is O(n) times O(n). So the complexity of the first code segment is O(n) square, not O(n). Pay attention. However, if we use the iterator, now if you look at the loop body, in every iteration, say the last one we looked at was the element with index 1000. Now we want to look at the element with index 1001. Doesn't matter, it's just moving by 1, because the iterator from the previous iteration was left at the element just before the one I'm trying to access now. So the operation I need to do is just a single move, not starting from the beginning and counting 1000 elements. So here the highlighted loop body has O(1) complexity, and the loop iterates n times, so the complexity would be O(n) times O(1), so it's O(n). Whereas remember, for this one, the complexity was O(n) squared. Although at the first glance it appears to be like O(n), but actually don't forget that the get method itself has O(n) complexity. So how do you use it? The usage is simple. You say iterator of something. This E is the type of your list. It could be either an array list or a linked list. Typically we use it with linked lists, and as we will discuss in the next section, with also sets, so in general about collections. But if it's a list of string, then for E you should put here string. If it's a list of student, then you should say iterator of student. So whatever the type of the element of the list is, that type should be written here. Then your variable name for the iterator. And initialize it using the iterator method of the collection you're talking about. It could be a list, linked list, array list, and as soon we will see, it could also be a type of set. But you need to call the iterator of that collection. Note that the right-hand side here belongs to a collection, and the left-hand side belongs to an iterator. And the type of the element here for the iterator, don't forget, should be same as the type of the collection here. And what we're doing altogether in this line is we're initializing as our iterator by attaching our iterator to the first element of that collection. So you have to create that association between the collection and the iterator, because in your program you could have many collections, and now you have defined an iterator to which collection does it refer to. So you should do that that association yourself. Once you've done that, then you should access everything through the iterator. You should use the hasNext method on the iterator, next method on the iterator. Here's an example. Assume we want to remove all strings with even number of characters, in other words with even length, from a linked list, but in an efficient manner. So I don't want to have a for loop that starts from the beginning and uses get method, because we know, we have discussed that it's not efficient. So we use the iterator instead. So our method name is remove even length. It takes a parameter of type linked list of string. Therefore, my iterator should be of type string. I will name my iterator as I, and I do the association between the iterator and the list using the iterator method of the collection. Here its name is list, which was my parameter. So whatever parameter is being sent to me as a linked list of string, I call its iterator method so that I can attach my iterator named I to this parameter. Once I've done that, I work only using I, not list. So I call hasNext of I. If it has a next element, I can retrieve that element using next, but don't forget we said when you retrieve it, immediately the iterator will move to the next one, so you will not be able to access the same value again. Therefore, don't forget to store it somewhere. So I store it in a new variable, say element. The type of element should be the same as the type here for the iterator, because I get that value from the iterator, which would be the same as the type of the parameter here, because the iterator was attached to list. Anyways, now we've got in element the first string in this list. So let me check its length. If it's even, then call remove, but pay attention, not through list, but you call remove through the iterator. So the iterator structure provides us some benefits. As we have seen, it provides us a speed up. It's used both for lists and linked lists, for linked lists, array lists, and even for sets, as we will see. But especially for the case of linked lists, it provides us a significant speed up when we are trying to access the elements of a linked list in a sequential manner from the first to the last. It also provides us a unified way to examine all elements of a collection, so independent of whether it's an array list or a linked list, or soon we will see the sets if it's set, we're always using the same method to access them. So every collection in Java, as I said, has an iterator method. For the case of some structures like the sets we're going to discuss, it provides us actually the only guaranteed way to examine all of the elements, because in the case of sets we will not have that index. In the case of lists, at least we had the index, so even if it's slow, I could go one by one. In the case of set, I don't know where each element is. There's no ordering for them, so I cannot access them through an index. Related to what we said over here, since it's a unified way, we don't need to look up different collection names, and also it doesn't require us to go through the indices. However, the iterator also has its downsides. For example, look at this example. We have a linked list and we set up an iterator on that. This time our linked list is a linked list of integers. Remember, integer is a wrapper class for int, because you cannot say iterator of int, because int is not a class name, but integer is a wrapper class, so you can use that. So we set up the for loop, because what we are trying to do is we are trying to find the odd valued elements, but we also want their indices. So here we need to count the index. So we have a loop counter initialized from 0. In each iteration it's incremented by 1, as long as there is another element to look at. If so, take that element, check if it's odd. If so, print both the value and also the index here. So in this case, for example, there will be cases where we still have to keep an index variable. And one important thing is we cannot use the iterator to add or set elements. The iterator is programmed to crash if you try to modify the list by a way other than using the iterator. So here's the example for that. For example, we want to add a 0 after any odd element. So similar to the previous case, we go over the loop and we try to find the odd values in the list. And if so, we try to insert an element after that position. But when you try to do it, it will crash. That's how the iterator is programmed. Because, well, if you're trying to access the iterator, access the elements over the iterator, then you should not be modifying the list in a way other than the iterator. We have called here the add method of list. We are not doing the modification over the iterator, but over the list object. The iterator, don't forget, speeds up only get and remove loops. It does not provide us add or set elements, set methods for modifying the elements. Actually, there is another data structure called list iterator, but we'll skip that. We'll not go into that detail here, which is more powerful than the iterator, but it is specific to only array list and linked list. As the name implies, it's a list iterator, whereas the iterator we discussed is a more generic definition, which works also for the other types of collections, like for the sets. When you try to make such a modification, you will get an exception named concurrent modification exception, because you're trying to modify the list in a concurrent way through some other means. However, when you say remove, this will not cause a concurrent modification exception, because this time you're doing the remove operation over the iterator itself. Finally, let's look at this example. We want to write a method named longest, which will take a parameter and find the longest string in this list. But note that the type of our parameter is not array list or linked list, it is list. Now, if you remember the figure we covered several times, where we had the hierarchy, at the very top we had the collections, which was again an interface. And from the collections, we derived either the list interface or the set interface. And we said the list interface was implemented either as an array list or a linked list. Okay. Also remember that list was an interface, array list and linked list were classes. So here what we're doing is we're defining a method which takes a parameter of type some interface, list interface. Not a class name, but an interface name. But list was an interface of some generic type. So here in this example, we make it a list of string. But don't forget that list of string still is not a class, it's an interface. Now this variable, actually the parameter list, is defined of this type. Since it's an interface, you can define variables of the interface type, as we discussed earlier in polymorphism, but you cannot create objects of interfaces because it's not a class. You cannot create an instance from an interface. So we have defined list to be of this type. That means I can pass to this method, I can pass any parameter that is a descendant of list. Remember, array list claimed that it was implementing the list interface. So I can, for example, create an array list of string. It has to be of type string, pay attention. So I can create an array list of string and pass it as this parameter, because array list of string is a type of list of string, because array list implemented list. Similarly, you can create a linked list of string, and you can also call this method, because linked list was also implementing list. So as long as the element type is again string, you can pass a linked list of string. This method will work for both array list of string and linked list of string. Anyways, once we get this parameter, we're creating an iterator. It has to be of type string because this was a list of string, and we're calling the iterator method of that, because the iterator method was enforced by the collections interface, and the list interface was a case of the collections interface. So we initialize our iterator. So from now on, we're going to work through the iterator. So when you say I.next, it will get the next element from this list. No matter if it's an array list or a linked list, you can still call this next method through the iterator, and you get that element into result. Here we are assuming that the list has at least one element. Okay, so so we get the first element into a variable named string, named result, and then as long as we have further elements, you read the next element and immediately store it in a variable. Here we named it again as next. So for example, element with index 0 was in result, element with index 1 is in next. So I'm comparing the element in index 1 against the element in index 0. If this new element is longer than the previous one, result will contain the new one, the longer one. If not, which means the previous one was longer, you don't make any changes, so result keeps on storing the longer one. So in every iteration of the loop, at the end of the iteration, result contains the value that is longest up to that point. When you reach the end of the list, then result will be containing the longest in the whole list, and that's what you're returning. So this way, we will be able to find the longest string element in a list of string where we can pass either an array list of string or linked list of string parameter.